The motion of a bouncing ball is something dynamic that you see every day. So I will be calculating the coefficient of restitution based off of the height of a ball. So if I were to throw a tennis ball and its initial bounce had a maximum height of 12 feet and its second bounce had a maximum height of 5 feet, can I calculate the coefficient of restitution? So this problem will involve work energy, conservation of momentum, and impacts. So first thing is you have to draw your diagrams. So I made 4 states 1, 2, 3, and 4. 1 and 4 are the peaks of the bounce, so that's when it has the most potential energy. And states 2 and 3 are right before and right after the impact, so that's when it has the most kinetic energy. So in state 1, it has a velocity x and a height of h1. And at state 2, it has a velocity x2 and a velocity y2 in the downward direction. And then directly following the impact, it will have a velocity y3 heading upwards and a velocity x3 also heading to the right. And then the final state will be h4, where it has a height of h4 and it has a velocity x of vx4. So now that we have all our diagrams out of the way, we'll try to use some equations to help relate the different states together. So the first thing I did was I did conservation of momentum. So I did the integral of the forces in the x direction over time is equal to the change in momentum in the x direction. So since there's no forces in the x direction, we know that the momentum is constant in the x direction, therefore vx1 is equal to vx2 is equal to vx3, which is equal to vx4. So they're all just denoted as vx. So next off, I did conservation of energy. So energy is not conserved through the impact, but it is conserved from the peak to right before the impact. So I did the energy at state 1 is equal to the energy at state 2, which is right before the impact. So you have your most potential energy, which is mgh1, plus 1/2 mvx squared is equal to 1/2 mvy2 squared plus 1/2 mvx squared. You can cancel out the 1/2 mvx squared terms and simplify to get that your velocity in the y direction, the magnitude of it at least, is equal to the square root of 2 times gravity times your initial height. Now, you can also apply this to states 3 and 4, or diagrams 3 and 4, and you will find that the velocity directly following the impact in the y direction is equal to the square root of 2 times gravity times your final height. Now, you can calculate the coefficient of restitution as the ratio of the velocity of separation over the velocity of approach. So that's just going to be velocity y3 over velocity y2. And so that simplifies to the square root of your final height over your initial height. And so for this case, our final height was 5 feet, and our initial height was 12 feet, so we can calculate that our coefficient of restitution is 0.645. Thank you very much.